Continuing on with chapter 21, the effects of a warmer world. So with all this global warming activity going on, and we know the planet's warming, it's again, whether it's anthropogenic or not, poorer countries going to get hit definitely the most. Of course, in the United States, we have lots of money, we can deal with this, we'll get around it somehow. Premature deaths from side effects, increased disease. Of course, side effects can be everything from drought to lack of food. Plants and animals will have to adapt, and things like insects are going to very easily, of course, being selected, and they'll flourish. Wildlife reserves, wilderness areas, wetlands, coral reefs can be threatened with loss of biodiversity. Again, something as simple as temperature change in the oceans for coral reefs are devastating. The algae in the symbiotic relationship with polyps actually tend to leave, and that's when coral bleaching occurs. Tree deaths due to disease too. Keep in mind that our biomes are actually going to shift, so what we're going to go up into Canada, and we'll get what's in kind of the St. Louis area. Wildfires in forests and grasslands, destroying habitat. Of course, what that's going to do is release even more CO2 in the environment, so again, a positive feedback loop. Most likely disrupted are, of course, coral reefs, polar seas in particular, and that's occurring already. Coastal wetlands, Arctic and alpine tundra, high elevation mountaintops. So that tundra in particular, which usually has permafrost, is starting to melt, and of course with anaerobic bacteria, and speeding up the global warming even more. Food production is going to vary. Warmer temperatures could shift to growing areas north. Less fertile soil may reduce food. Now, if what we grow in Wisconsin, like corn, needs to be shifted into Canada, it's not going to work really well because they have a lot of conifer trees which release needles that have acid in them, which is actually going to make for very poor soil. Less snowpacked areas could result in less water, crop and fish production reduced by rising sea levels that flood deltas too, so we're going to get Here's a couple of little things, nice graph in your book. Agriculture, everything's going to shift. Water resources, of course, a lot of people that rely, again, like out west, on the water from the mountains. That may not occur anymore. Forests are going to change. Biomes are going to change. Sea level, of course, we've talked about. Human health could change too. We could get more disease. Remember, bacteria, virus really like warm weather, so if we have warmer weather, of course, that's perfect for disease to flourish. We're going to have increased deaths. We're going to have environmental refugees. They're stuck. What can they do? If they can't adapt to it, obviously they're going to have to move, or they're not going to make it. Weather extremes, we're already seeing that with increased storms, of course, on the East Coast, and increased intensity of hurricanes, and biodiversity. And a couple projections here on what temperature is going to do. On the medium end, what's going to happen is areas like Shanghai, New Orleans, other low-lying cities are going to become underwater as our thermal expansion. Here's a little picture, a couple things to note on here. Look at Florida's gone. The Mississippi Basin right there is all flooded out. This area up in Canada is quite a bit more flooded. Brazil flooded, down here flooded. If you take a look, I know one of the areas that's going to be hit are the island nations of Malaysia, Indonesia, throughout in here. A lot of Russia flooded up in this region right here, and of course the Antarctic rather. A lot of this region down here is flooded. So a lot of coastal regions, even along the eastern coast of the United States. Think about any lowland hammered with flooding at its extreme point. So increasing sea levels, of course, coastal areas like New Orleans, which New Orleans, of course, is 3 feet below sea level in the first place, so it's not going to take much. Disrupt coastal fisheries, coral reefs, flood barrier islands gone, flood agriculture, low lands, of course, are going to be flooded even more. Think about in northwestern Wisconsin where they have the cranberry bogs. That's a very low-lying area. That could get flooded out. Contaminated freshwater aquifers with salt water. We're already seeing that a little bit because we're overdrawing salt, or groundwater rather, and it's going to submerge. So what do we do? Our economic costs of reducing greenhouse gases higher than the economic benefits. Should developed and developing countries both take responsibility? And of course, areas like China, which are producing lots of carbon dioxide now with increased coal burning, really should get aboard in this. Do more research, wait and see strategy, probably not. Act now to reduce risks, yes. And of course, that's what the Kyoto Principle actually attempted to do, but not everybody like the United States signed on to it. But we needed to act. 3 major strategies to slow the rate of global warming, improve energy efficiency. We're doing that with cars as an example. Shift from carbon-based fossil fuels to a mix of carbon-free renewable energy resources. A lot of European nations are ahead of us in that regard. Sequester as much CO2 as possible in the soil, vegetation, underground, and deep ocean. So one idea is with all this fracking that's going on, and of course with all this fracking that's going on, we have decreased volume below us, and we're seeing increased things like ground shaking of earthquakes. Why don't we pump the CO2 back in there? Maybe that'll stabilize it a little bit. Who knows? But we could take some of the CO2 and put it back into the ground. The problem is expensive. So here you can see, for example, here's an oil rig that is probably done. What could happen is then we could pump the CO2 back into the ground. We can store it here. A very good idea is growing things like switchgrass. Switchgrass is actually a good cover crop, and it absorbs a phenomenal amount of CO2, so we could use that. Techniques to remove CO2, of course, storing it in biomass, plant more trees. Trees absorb that carbon dioxide from the environment. Again, soil sequestration, which is when we can plant things like switchgrass that grow very quick and absorb lots of CO2. Of course, reduce the release of CO2 and NOx's in the first place. We can do conservation cultivation too, which doesn't till everything up and release that into the environment. Remove CO2 from smokestacks. We need to get some sort of scrubber that's affordable for companies to do to get that CO2 out. Deep injection wells, of course, maybe government should tax. Increase subsidies for carbon-free industry, so let's pay people, industry that do things like wind power and solar power. Technology transfer from developed to developing countries. Costa Kyoto Principle 1997 required 39 developed countries to cut emissions of carbon dioxide, methane, and N2O by 2012. 120 countries have ratified it. Unfortunately, in 2001, President Bush withdrew. The United States argued that developing countries need to comply too. A lot of developing countries like India and China, which are huge CO2 emitters, of course, did not sign in on this. The biggest emitters of greenhouse emissions now are the United States, China, Russia. Great Britain, great job, reduced emissions significantly by relying more on natural gas. Natural gas is still a pollutant, but it doesn't nearly pollute as much as coal or burning pure petroleum. Improved energy efficiency, high tax on gas too. Between 1997 and 2000, China really reduced its emissions by 17%. Ours actually rose by 14%. A lot of businesses, college really take the lead on this. Companies like Toyota, 3M, DuPont, Shell have really gotten advanced on this and kind of headed toward a carbon-free electricity. The reality is all countries really process though. All right, we're going to swing gears over to the ozone. Of course, the ozone is in the stratosphere. It is O3. What it does is it protects us from UV radiation. If it did not protect us from UV radiation, what would happen is we'd literally burn up. What is depleting the ozone are chemicals like CFCs. CFCs are chlorofluorocarbons. They're used as coolants. They're in aerosol cans. What happens is they get up into the stratosphere, and they are actually something that breaks down our ozone layer. They're insoluble in water. With the help of UV, these CFCs actually break down into the individual components and release things like the chlorine, and that chlorine kind of acts as a free radical and breaks up our ozone. So CFCs plus UV radiation can give us chlorine, fluorine, bromine, iodine, and what happens is those break ozone or diatomic oxygen and oxygen. CFC's a little history, actually discovered in the early 1930s, actually 1928. Chemists developed a family of CFCs, including Freon. Freon is used as a coolant. Very inexpensive. The problem is they remain in our atmosphere since they are insoluble in water and chemically unreactive. They're lifted into the air by convection currents and broken down by UV rays. Chlorine is released, causing that ozone to break down. They can stay in the atmosphere for 65 to 380. As you'll see, we've greatly reduced CFCs. This is a huge success story, but because they're persistent, it's going to take a long time. Other culprits that come into play are halons. Halons are actually generally fire suppressants that are used used to be used like in restaurants. We don't use those anymore. Hydrobromofluorides, which were in fire extinguishers. Methylbromide, which is a fumigant. Hydrogen chloride was actually ozone depleter. What you can see here is in 1987, we had the Montreal Protocol right here. The total ozone and it's being depleted, particularly in the Antarctic region. What happens is in Dobson units, it's about 325 roughly here, and you can see by the time the Montreal Protocol came into play, we're down to about roughly 175 Dobsons. So it is depleting. That's an issue because of. So you may or may not have heard of the ozone hole, which is over the Antarctic region. It's where our ozone is thinning. For 4 months a year, up to half of the ozone in the stratosphere over Antarctica is depleted. What happens is, and remember they're in the southern hemisphere, so everything is flip-flop from what we are. What happens is in our summer is their winter, they have these polar vortex, which is very cold, it's very windy down there. And what happens is their air molecules actually crystallize because it's so cold, and it hangs on to these chlorine molecules. Well, then what happens is when their summer returns, which is in October, remember we're going into winter, is that sun actually stimulates the CFCs to break down, and the chlorine will then break down the ozone and deplete it. Another reason it actually occurs down in Antarctic region is actually because, remember at our poles, the poles are much thinner as far as the atmosphere goes than the equator, so it's much thinner down there. This can actually lead to ozone in the troposphere over Africa, Australia, and South America, which is a respiratory irritant. So this just kind of shows the partial pressure of the atmosphere. Altitude-wise, what happens is, of course, our partial pressure actually. What can happen is when we get UV rays down into us, UVA actually can penetrate deep into our skin. UVB is the one that we really need to worry about. That skin cancers, you can see a couple different types of skin cancers. Squamous cell carcinoma right here, that can be, if it's caught early, dealt with pretty easily. This is the bad one right here, which is melanoma. And then, of course, basal cell carcinoma. It's called that because it's in our basal cells. That's carcinoma there too. So UVA rays have the longest wavelength. They're followed by UVB and UVC, which have the shortest. UVA and B are the ones that are transmitted through the atmosphere. UVC and some UVB rays are absorbed by the Earth's ozone layer. UVC is actually used to make the ozone. Most of the UV rays you come in contact with are UVA. Small amounts of UVB have short wavelength that reach the outer layer of your skin, the epidermal layer. UVA have the longer ones, of course, that can penetrate the middle layer of your skin, or the dermis. As I mentioned before, squamous cell and basal cell are due to years of exposure to UVB, very curable if caught early. Malignant melanoma, unfortunately, is the one that malignant. It spreads throughout the body. It kills 1/4 of the victims, and unfortunately, normally they're under the age of 40, and these are the ones that are out in the sun a lot or in tanning beds. Tanning beds can actually increase chance of melanoma by 55% if you use it. Kind of scary. International Agency for Research on Cancer, known as the IARC, found that tanning beds emit mainly UVA at close range. An association between indoor tanning and two types of skin cancers, squamous cell and melanoma. Association between UV emitting tanning devices and cancer of the eye, ocular melanoma. This is why if you go to tanning beds, they have you wear those little goggles because you don't want to damage your eye. UVA and B rays do cause DNA damage, which can lead to skin cancer. Risk of melanoma, of course, of the skin is increased by 75% when tanning beds use is before age is significant. Now, what happened with the ozone depletion? A very key date was 1987. A bunch of very smart people got together in Montreal, and what they did was they decided we need to get rid of CFCs because they knew it was depleting the ozone, thus raising the radiation level. If we had no protocol at all, what would happen is we'd have increased CFCs out there, and of course increased skin cancer. So just the 1987 Montreal Protocol alone really reduced it this much. And then in 1992 we had a Copenhagen Protocol which reduced the level of CFCs even more. And we've had a very key thing in 1987, of course, was the Montreal Protocol, when we realized that we need to stop these CFCs, and they reduced it by 35%. In 1990 and 92, we actually had the Copenhagen Protocol, which actually there was amendments to accelerate that phase out really quickly. CFCs are banned now, or it's illegal to make them and use them. These were signed by 177 countries, including the United States, and our CFC output has pretty much gone to nothing and still in the environment because it's persistent. The thing is, with restoring the ozone layer, one thing it does is it prevents UV radiation that's trapped in our environment right now from escaping. We need to do that, and that's the other side of it, to protect, obviously, our skin. Anyway, that's it for Chapter 21.